Well, I am delighted to welcome Steve Rose, Vice President of Product at PhysicsX. Steve, thanks so much for joining us today.
Thank you for having me.
And joining us from AWS, we have our Senior Partner Solutions Architect, Fernando Espigares. Fernando, great to see you.
Great to be here. Thank you for having me, Sara.
So, Steve, for our international listeners, can you give us a little bit of background on PhysicsX and what your mission is?
As PhysicsX, we're here to accelerate engineering by using AI. We do that across a variety of industries, from automotive, aerospace, materials, semiconductors. And what we're looking at is using AI to replace simulation. So lots of engineering companies use simulation to understand the performance of something before they make it in real life. The challenge with that, though, is that numerical simulation is really slow. It's computationally expensive and it's very slow. There's complex mathematics going on in the background, understanding the physical world and our representation of that. And so what we're able to do is to train deep learning models to understand these numerical simulations and produce the results in a fraction of the time. So taking something that in a simulation that might take days or hours to produce a single result of how something might perform in the real world, we can do that with inference in a few seconds. And that really transforms how engineering companies are able to understand their products before they make them, which enables them to test things much more quickly, understand them much more quickly. And then a really interesting twist on this then is getting into areas where, because of the time it took to run numerical simulation, it can't always have a place to play. So if you think about an operational context, if somebody's waiting to make a decision, you can't wait 2 hours or 3 days for a simulation to run. So you have to make a decision without that. With inference, suddenly you can actually make physics-informed real-time decisions, and that opens up simulation to a whole set of new areas in operational contexts as well. So right the way through the engineering lifecycle, from early stage concept design, right the way through to operational manufacturing into operations as well, really enabling simulation to be used and much more quickly than would ever be possible before.
Amazing. So probably reducing the cost of doing those simulations as well as speeding it up, and also love the idea of opening that up to a broader range and just faster iteration too for innovation, right?
Absolutely. And
quality.
Absolutely. So we kind of think about, time to market is so important for many of our customers.
Right.
And we can, what would have been a very slow iteration cycle that would take days or, to do each iteration, we can cut that down, from iteration times taking months to within a day, which dramatically accelerates how quickly people can get products to market. So there's a huge saving there, both in terms of the cost of doing that engineering, but in terms of getting your product to market faster.
Absolutely. Well, tell us a little bit about how you came to work with Fernando and his team.
Yeah, so I guess the starting point was really through the AI Accelerator program. We got involved with that. We won the prize for generative engineering. So we used that as a fantastic opportunity to train our first foundation model. And through that, then we started to explore, how we could use all the various different AWS services to really get the most from the prize that we were awarded at that point in time. So what we were able to do was really think about how physical objects can be defined in a generative way, such that we can very quickly iterate and optimize for customers there. So that was the starting point, if you will, of our relationship there.
Wonderful. And Fernando, tell us a little bit about this competition that they won. Congratulations, Steve.
I mean, it's not really a competition; it's more of a program that we do. But there is obviously a competition factor in it, because it's a very let's say selective program where only like 2% of the candidates are actually selected and go through the actual funding program and could benefit from all the advantages that we put on the table. So this program is called the AWS Generative AI Accelerator. We use the short term GAIA, as well as like the code name of the project, and it's focused on startups, and the goal here is to accelerate the development of their solutions. We at AWS understand the value of startups because they are the ones really innovating and challenging status quo for many industries. And I still remember the first time I was exposed to PhysicsX, because I'm kind of a engineering nerd as well. I like the aerospace and those kind of things. First time I understand that, wow, this has the potential of actually making a real impact on many. I mean, the field is very broad. I mean, when probably obviously PhysicsX is focusing on specific industries where they see more value, but I think this has the potential to actually influence a very broad range of engineering topics. So it's kind of like when you have a tool that enables you to do more innovation faster, explore additional angles to the same problem. So I think it's really game changing. So yeah, and they were selected, and then ever since we are working with them, as Steve mentioned, there is part of it which is financial support. Obviously, there is AWS credits to support the development of a product. But there is also, once we have a viable product that is enticing to the enterprise, there is go-to-market support, there is mentorship on the early stages. Obviously, they are already over on that stage. And also the access to the network that AWS has as well on customers. So I think it encompasses the full life cycle of the startup.
Yeah, absolutely. Tell us a little bit about the approach that you took, what you were doing before you were able to train the model, and then kind of how you iterated on this, Steve.
Yeah, so the really interesting thing around optimizing physical shapes is how now we can assess the performance of a physical shape if you've got one. The challenge then is how do you generate a new shape and keep generating shapes so that you can find the optimal. And now the traditional way of doing that is you take a CAD drawing, something that describes how what the part looks like, what the system looks like. And then you can parameterize that, so you can change different things on that. Each of the things you parameterize needs to be manually laid out and drawn, and that's quite a lot of an effort. And if you think about a part, you can't just suddenly sort of strip one bit out of that part, because you've got you might have a curve and it will distort things and will change things. So parameterization is quite a complex piece to set up. And so when we're thinking about how do we accelerate engineering so that we can get to that design faster, we don't want to put people through the pain of parameterizing CAD models all the time. And so we wanted to take a generative approach to this. And the way we were conceiving this was having a large geometry model, effectively a model that allowed us to describe any physical shape in a very succinct way that we could play with and morph and change and get different shapes out of that, such that we could do an optimization on that. And so what we did with the GAIA program was to train this large geometry model. And what that did was took a shape in at one end of the spectrum. It would then encode that shape into a set of numbers, and that's an encoder. And then from that set of numbers, 1,000 odd numbers, describe that shape completely. And then you write a decoder to go from the set of numbers back out to a shape again.
Right.
And what you can then do that's exciting is play with those numbers that you've got, and you can generate any number of shapes that haven't been seen before or generated. And so the model, the foundation model we generated was really an encoder and a decoder that were both deep learning models that understood how to go from a physical shape to an arbitrary set of set of numbers. We didn't define what they were. The model learnt the right set of numbers, the right way to describe these shapes, and so that we could accurately go from a shape to a set of numbers and back out to a shape again. That really gives us the opportunity to say, well, you can then play and morph and see what happens with all these different shapes that have never been conceived of before. We trained it on aeroplanes, we trained it on birds. What do the shapes look like in between those two? Well, you can play with this latent space and explore and find all sorts of new shapes that have never been explored before. And then with that, you can then start to really run an optimization. So it breaks through this problem of how do you generate shapes such that you evaluate it and find new shapes. So that was kind of the crux of what we did. with the GAIA program, and on top of that, we then built a physics model, which not only went from shape to latent space to shape again, but on the way back out could also predict the physics at the same time. So if you've got a flying object, then let's understand the lift, the drag performance of that on the way out again. So you can go from an arbitrary, a set of hundred odd numbers to a shape with a whole set of information about its lift, its drag, and its aerodynamic performance with that, which is super powerful if you think about how to, explore different flying, in this case, flying objects or any other sort of aerodynamic performance of a pipe, a tube, or whatever you're looking at.
Right. Yeah. Fascinating that you're using objects or shapes that occur in nature and then man shapes and looking at kind of the that's very interesting. And talk us through a little bit, Fernando, of the architecture here.
Yeah, I mean, in the end, when we speak normally about Gen AI, we always have the large language models in mind, which are text-based. It's not that different from what Steve has been discussing, but the approach is completely different, right? They're building similar kind of encoder decoder architecture, but applied to a completely different set of data, right? And I think that's very interesting. Now, from the point of view of, let's say, the deployment or how do PhysicsX fits into the AWS infrastructure and services, I think the obvious first service that comes to mind is SageMaker, because it has been used for developing machine learning models for many, many years in AWS. And for sure, PhysicsX has been deployed, the model on SageMaker deployments on some engineering customers here in Europe and around the world. And I think that brings the best of both worlds, right? The services and infrastructure that is familiar to enterprises that have been using them for deploying and developing new services and new engineering innovations, coupled with new innovations from the generative AI side, like PhysicsX, and this unlocks like I love like Steve mentioned, like the exploratory options of engineering, right? Instead of having a rigid design that you have to agree before, because it's very expensive, let's call it like that way, to actually run the entire simulation. Now the engineers have more freedom to actually innovate, and this innovation is powered obviously by innovations out as well on infrastructure and services from AWS. Be it on SageMaker, obviously powered by EC2 instances, built on top of Nitro, which is proprietary silicon developed by AWS, and all those technologies compounded is what delivers the value to the business. So it's not only AWS services or not only PhysicsX model, it's the conjunction of both. The better together story, I think, is what resonates here well with customers.
Right. And Steve, that so your customers would be other firms that are developing airplanes, cars, trains, etc. Is that right? Yeah.
Absolutely, yeah. So equipment manufacturers of all types, or heavy engineering as well. So we cover a very broad spectrum of engineering, and we found that the model architectures that we have that describe physics are actually incredibly versatile, and they're able to describe all manner of different types of physics, from aerodynamics I've mentioned, to structural information, to chemicals. We're finding a very, very diverse range of applications for this type of modeling, and so that really gives us very broad reach across a very wide spectrum of engineering. And I think each of these has its own variance in terms of what is it interested in, which combination of physics. And so one of the really powerful things we're able to do is bring in all these different types of physics into a single AI model, and provide answers across something that would have taken many, many different types of simulations before. We can bring that all together into one place and optimize all at once. And being able to host that inside, do the training at scale with AWS is an incredibly powerful combination for us.
Right. Fascinating. Steve, we often talk in this podcast as we're looking at, sounds like this is something that's very new to the world, this is the kind of cutting edge innovation in the engineering space, and we often talk about sort of innovation and failure being inseparable twins, right? Tell us a little bit about like what were some of the challenges that you had to overcome, or some of the failures that you learned from and pushed through.
Yeah, I think there's obviously a learning journey with all of these things, as you say, from specifically from the models that we were developing together on this GAIA program. It's interesting to think the shapes are very interesting. Can you how useful are they all the time? In a real world, you've got to think about, can you manufacture the shape that's been generated? Can you, is it viable or sensible to make it? Is it too thin to be manufacturable? So these sort of real world tolerances, constraints that you have to factor into, that a purely sort of abstract model doesn't have to worry about. Doesn't have to worry about an object fitting in a certain shape and things like that. So it was interesting going from the journey of, we've got a fantastic model. How do you actually use that in real world engineering? There was a journey to go through there, which, we had to work through step by step in terms of, how do you constrain the model? How do you constrain what it's outputting? Because you could just test every single output that it produces and says, is that useful for engineering or not? Can it be made? Can it be this? But actually starting to bake some of these constraints in is a really interesting part of the journey, to go from the academic world that
right.
AI starts into the real world engineering, or any of these topics have the same challenge of, the theory is fantastic. How do you actually get that consumed? And I think that's been a really interesting journey. And the other one, which hits every big B2B play, is really understanding where you fit in the ecosystem. And it's very easy to, I've got a fantastic tool, fantastic new idea. I'll wrap that in a tool, and it'll be useful for people. And I think it's so important really early on to think about the ecosystem that you're embedding your capability into. How can this be consumed? Nobody really wants an extra tool in their tool chain. Problem solved quicker, but they don't necessarily want to switch between tools and learn something new. How do you integrate these things? What's the system of record for all the pieces of information? Where you're getting the information from? Where is it going to? What is the central source of truth for these bits of information? Or are you in the new system of record for some of this data or some of these insights? And so thinking about those really early is really important, and something that we put a lot of effort to, particularly recently, and how we form an active, healthy part of the ecosystem, which is different for every customer. And that's the nature of the beast in B2B. Everybody has their own tool chains. We need to be able to slot in seamlessly to those, integrate with them, and become a part of that ecosystem. So I think that's the other bit that's been really hot of mind in the last 12 months, particularly, of being able to be part of an integrated ecosystem, not being an island, a tool of excitement on the side, but something that can get adopted. So that's the other big push that we've made over the last 12 months, is being a part of our customers' ecosystem, so they can easily adopt and consume this without export, new tool, import.
Right.
And that's I think that's a very important topic as well, is security, compliance.
I was going to say, exactly.
Because that's something that obviously we can help with as well from AWS, and we are doing investments right now here, even in the European Union, with the European Sovereign Cloud that we are going to launch by the end of the year. And I think that it's the better together story that we were discussing before, right? It's not only about the technical solution; it's also about how the solution fits into existing workflows of very sensitive industries, especially in the case of PhysicsX, right?
Yeah, completely. And the designs we're dealing with are future new streams of the companies. This is their future business, so they are very sensitive of that. And so when we're deploying, we very often deploy into our customers' virtual private cloud. So they will have an Amazon account. We will deploy into that AWS account, and manage the security in a very careful way. And that's something we we work very closely with, and we're very, we see as a big differentiator for us in terms of being able to be trusted and scaled across enterprises is such an important part of this business. We can have the tech, but unless it's, as you say, it's trusted, it's secure, and it's able to handle in a trusted way this really sensitive information, it can never get adopted. And so I think this is a really big piece that together we bring to industry.
Fully agree.
Absolutely. Tell us a little bit about where you are. Give us a sense of kind of, do you have some active customers actually kicking the tires here, or where are we in the or maybe designing tires to kick, I guess?
Yeah, yes, we have we've got a number of customers. We're very fortunate that we're we're in a really good position there. Getting really strong adoption. We've got offices, London headquartered, New York as well, and we're expanding from there. And really focused on where our customers are and being close to our customers is really important for us. So yeah, we're seeing incredibly strong results actually from our early work with our customers. We've been working with some customers for several years now. They're getting, the fact that people are coming back to us says a lot. They're getting repeat benefit from our technologies, and now the challenge is scaling, and this is where actually our GTM relationship with Amazon is starting to really bear fruit as well, and we've got a couple of live customers that we've developed together. So that's a really strong and important part of our go-to-market motion as well.
Well, give us a sense of scale when you have a customer who's manufacturing a certain piece of equipment or a vehicle or what have you. What does that scale look like for one customer? And then obviously you're scaling it out to reach multiple customers, but this is hundreds of simulations that would happen or iterations that would happen per day, or how is that?
Yeah. There's kind of a few parts to the journey. The first part is generating the data to train a model.
Yeah.
Even if you use one of our foundation models as a starting point, you will still want to fine tune that model to make it particularly accurate in the areas that you care most about as a company.
Okay.
So many of our customers will take our model and fine tune it. Others will take one of our model architectures and train that from scratch. So the first part of the journey is really data generation.
Mm-hmm.
So what we do is we take existing simulations, and most of our customers have simulation solvers of their choice. They'll be using ANSYS, they'll be using Siemens Star CCM. They won't want to change that tool chain. So what we do is we use the existing simulation tools they have. We're able to orchestrate those. We'll put them in the cloud. We will be able to batch run and generate large quantities of data to enable us to train our data. So this might be, when I say large quantities, it could be 80 samples, 80 simulations. And if you imagine a simulation could take several days, weeks.
Mm-hmm.
One of the nice things we have is our data is very high quality. It's not noisy because it's simulation data. We know exactly what the input is and exactly what the output is, and we have high trust and confidence in that output. So the reason we can get away with quite small, relatively small volumes of data is because the data is such high quality. Sometimes we will run thousands of simulations. It really depends on the use case that's being sort of explored. So the data generation is the first part. We'll then train the model, and obviously training the model we'll do with on a GPU within AWS. And then the next piece then is to use that model then to optimize or to explore. And again, that might then be running tens of thousands of inferences on that model to explore and find the best result for what you're trying to optimize for. So lots of different stages, each of them kind of scaling in a different way.
Mm-hmm.
And our customers are naturally big, the automotive industry, semiconductors. As we scale through that, there are, thousands of engineers involved in the design of these pieces of equipment. And so scaling through those is kind of the piece that we're working through at the moment as we go from let's work with one group, one department,
Right.
go to the next one, go to the next one, and really sort of build out through the organizations.
Great. Okay. So increasing that scope and scale as you go and fine tuning also your operations, presumably, as you mentioned. Stephen, as we look into the new year, what's on the horizon for you?
Yeah, so obviously we've just done our Series B recently earlier this year, $135 million. So a really
Congratulations.
exciting amount of money. Thank you. that gives us the opportunity to really scale what we're doing here and have an impact across all of these different industries that we've been speaking about. So growth is a very big part of our story right now. We're growing rapidly internationally. We've got two big parts of our business. We set our business up with a product organization, which is the organization I look after. We are developing the core platform, all the capabilities that enable other people to build and train AI models on our technology. And then we have a delivery organization as well. And our delivery organization are forward deployed engineers working very closely with customers, ensuring that last mile is closed, pulling as hard as they can on the platform, building new features and building into customers so that they can get the most benefit as quickly as possible from us. And so it's two very, very exciting different parts of the organization, one working really closely with customers around the world, understanding their world in immense depth, and that enables us to have huge impact as an organization. And then our platform technologies behind that with all the complexity and scale that comes with that. So we're growing all the time. So if anyone listening is interested, always interested to hear from people who are excited about engineering and really sort of revolutionizing engineering in a way that's just not been done for many, many years. So it's a super exciting time for us.
It is.
Definitely. Yeah. Great. Fantastic. Um, well, Steve and Fernando, thank you for being here with us today to share a little bit about your journey and some of the insights that you've had and innovating in this space. Can you share a little bit about what you've learned, or what reflections do you have, Fernando, in working with PhysicsX that you might share with our listeners?
Sure. I mean, the importance of having a clear focus on prioritizing the use cases that you want to attack first, because I think that's having that priority list is super important. Also, I'm looking forward to PhysicsX to building like a wall model simulation, like because they already have the geometry, electromagnetics, chemistry. So
Yeah.
I'm pretty sure that we'll see that innovation coming forward. But yeah, it's having a clear understanding of what you want to achieve and prioritizing for impact. I think it's clear.
Yeah.
And not trying not to reinvent the wheel. I mean, if AWS can support you with existing technologies and infrastructure, why should you try to reinvest effort and energy in something that the outcome is not going to be that great? So I think it's having this opportunity of collaborating with such innovative startups here in the EMEA region. I think it's for me at least an honor and a pleasure. And looking forward to work with Steve in the future and on the future of innovation in engineering. So I think that's super exciting for me.
Absolutely. Steve, how about you? Any reflections that you would share with our listeners?
Yeah, I think getting involved with the GAIA program was fantastic for us. It gave us the real opportunity to test something that we wouldn't have ordinarily tested on our own. We could use those AWS credits, work with AWS, and really test a hypothesis that was reasonably high risk at the time. That gave us the confidence to then go forwards and start building our own foundation models from there. So that was a fantastic opportunity for us to really push the boundaries on something that we wouldn't have been able to unlock on our own very easily. So that was fantastic. And then the journey through and really investing the time in the relationship to move then towards the go-to-market relationship that we're growing now and very successfully. So that's a really powerful journey for us to, when I reflect on it, that journey from sort of testing a concept through to getting the confidence and to go away and build on that on our own and then turn that into a go-to-market motion is a fantastic journey that I would really encourage other startups to think about and really carefully pursue, because it opens so many opportunities.
Wonderful. Well, thank you both for sharing your journey and for those insights. And we're excited to see what comes next out of PhysicsX.
Thank you.
All right. Thank you.